different trig equations from Cambridge Worksheet exercise 4G. Solve the following for theta lying between 0 and 360. Now, the reason we're doing this exercise now is because we've just learned about trig identities, and we're going to use some of those trig identities to help us solve these equations. What do you think I should do first? Root 3 sine theta equals negative cos theta. What should I do now? Actually, yeah, that's okay. I'm going to divide by root 3. Actually, I'm going to divide both sides by cos theta. Actually, yeah, I'm going to divide, because look, if I just put the cos under there, I'm going to divide both sides by cos theta. So I've got root 3 sine theta equals negative cos theta. I'm going to divide both sides by cos theta. What have I got? Root 3 sine theta. Now, it does not eliminate. The only time you're allowed to divide by cos is if you've got, so this is a special rule for where you've got equations sine theta equals cos theta. When we divide by cos, what do we get? What's sine over cos? Tan. Now, we know that tan is sine divided by cos. So we actually haven't lost our sine and we haven't lost our cos. We've just rearranged it. Now, what's negative cos theta over cos theta? Negative 1. So this is just the same as solving tan theta is negative 1 on root 3. Okay? So where you've got sine and cos in your equation with an equals 0, or if you've got sine theta equals cos theta, or sine theta is negative cos theta, divide through by cos and you'll get tan. And now we're just solving tan theta is negative 1 on root 3. So what are our 3 steps? First step is, what's the negative for? Tan theta is negative in quadrants, what? 2 and 4. What's our acute angle theta? 30. So 2 and 4 with 30. And we're solving from 0 to 360. So therefore our solutions are theta equals, what have you got? 150 and 330. Now we're going to do another one similar to that. Question D. Solve sec theta minus 2 cos theta equals 0. All right. What do you think we should do? Yeah. But what is sec? 1 on cos. All right. Let's try. All right, let's take the 2 cos theta over. But we know that sec is 1 on cos.
Can you do the 1 plus tan squared?
No, there's no squares here, so we don't use 1 plus tan squared. So, we've got sec theta minus 2 cos theta equals 0. Sec theta equals 2 cos theta. We know that sec is 1 over cos. Wouldn't I just, doesn't 1, can I put the 2 down there? Isn't it this? Cos squared theta is a half. You okay with that? Because you're multiplying by cos theta and you're dividing by 2. You're rearranging. Do you know what to do now? So therefore cos theta is plus or minus the square root of a half, which is 1 on root 2. You okay with that? Sure you're okay with this? Because we've got 1 equals 2 cos squared theta. And then you bring the 2 down. A half equals cos squared theta. That's an intermediate step. Alright, now what do you do? All 4 quadrants. Yep. Acute angle is 45 degrees. So we've got 45, 45, 45 and 45. So therefore theta is 45. This one's 180 minus 45, which is 135. Is that right? 180 plus 45 is 225. 360 minus 45 is 315. Let's look at this one. Cos squared theta minus... actually, no. We're not going to do that one. Oh, it doesn't matter. Minus cos theta equals 0. Okay. I know it looks a bit weird. Don't use any squared rules. What can you do? You can factorize. So, cos theta is a common factor. Oh, no. I don't think I will. Cos theta, common factor. Cos theta what? Minus 1 equals 0. So, therefore, so if that times that is 0, therefore cos theta equals 0, or cos theta minus 1 equals 0. In other words, what does this one rearrange to give? Cos theta is 1. So all we do, we just draw our cos function. We good? 360, 180, 0. The others are 90 and 270. So, what are the solutions? For this one, the solution is, where does cos theta equal 0? Anyone? At 90, can you see it? And 270. And where does cos theta equal 1? At 0 and 360. So with this type, if you've got two terms, there's a common factor, you need to factorize. So therefore your solution is 0, 90, 270 and 360. That's your solution. I'm just going to choose another one. Now, see this one, just be very careful here. 2 sine theta cos theta equals sine theta. You are not to divide through by sine theta. This is not like, it is different to this. See this one, I know I divided through by cos. It's because I know that really I'm just putting the cos under there when I divide through by cos. It's because sine on cos is tan. You actually haven't lost anything. Because tan is sine divided by cos, you didn't lose sine or cos there. But here, if you divide through by sine theta, you are going to lose a solution. So what you do, when you're solving an equation, you always take everything over to the left-hand side and factorize, except for, in this case, because you can't factorize sine or cos theta. Right? So you can't factorize these. There's nothing in common. But here, see, the first one you could factorize. So if that cos theta was on the other side, you'd bring it over to the left, put it equal to 0 and factorize. So we're going to do the same thing here. Bring everything over to the left. So 2 sine theta cos theta minus sine theta equals 0. Now you can factorize. What do I get? Sine theta bracket 2 cos theta minus 1 equals 0. So I have to take two pathways now. Therefore I've got sine theta equals 0 or 2 cos theta minus 1 equals 0, and I need to solve both. So sine theta equals 0 is a sketch. Remember, for sine theta is 0, 1 or negative 1, we sketch. So what are my solutions to this? Yeah, where does sine theta equal 0? There, there, and there. Because remember I've got 1 and negative 1. So it's 0, 180, and 360. And over here, 2 cos theta minus 1 equals 0. That's really cos theta is what? A half. Okay? Take the 1 over, divide by 2. All right, what do I do now? What do I do? Yeah, cos theta is positive, so I've got cos theta is positive in quadrants 1 and 4. Acute angle theta is 60. Quadrants 1 and 4, 60. So my solutions there are 60, and 360 minus 60 is 300. So therefore you can just, or you can rewrite them. Theta is 0, 60, 180, 300. Oops, I've missed one. Or 360 degrees. Okay. Can't factorize this because there's a 2 here. Forget that. Everything to the left, you know, this is a quadratic equation. So you've got 3 cos squared theta plus 5 cos theta minus 2 equals 0. You can, if you want, let x equal cos theta, and it's one of these. What numbers, so wouldn't you have 3 cos theta and cos theta? All right, the factors of 2. So, like, I'm just going to call it x. 3x and x, right? If I let x be cos theta. I need plus 5x. Wouldn't I have positive 2, negative 1? Because this is like 3x squared plus 5x minus 2. So instead of x, I've got cos theta. So it would be 3 cos theta minus 1, cos theta plus 2. Let me just check. 3 cos squared theta plus 6 cos theta minus cos theta minus 2. All good? Now this is a question where you're not going to get an exact result. Actually, this is a question where you're going to have no solution. How are we with that? Girls, you okay with that? So therefore, 3 cos theta minus 1 equals 0, or cos theta plus 2 equals 0. So cos theta is what? A third? Girls, there's no exact value for that. So we're going to have to get our calculators out and do degrees and minutes. So cos is positive in quadrants 1 and 4. Acute angle theta. You need to go shift cos of a third. If it was negative, you would not put the negative into your calculator. If I do have a negative a third there, you don't put it into your calculator when you work out the acute angle. The negative, if there was a negative in there, it would tell me quadrants 2 and 3. Hopefully I'll get a question where we do that. All right, what have you got? 70 degrees. All right. I just need a bit more room. Quadrants 1 and 4, I'll just do it over here. 70 degrees, 32 minutes. 70 degrees, 32 minutes. So therefore, theta is quadrant 1, 70 degrees, 32 minutes. And quadrant 4 will be 360 minus 70 degrees, 32 minutes. So it's 70 degrees, 32 minutes, and 289 degrees, 28 minutes. Now that is the solution for cos theta equals a third. Now I need to look for my solution for cos theta is negative 2. Now tell me, I'm going to draw the cos curve. Do you think that cos theta can ever equal negative 2? Cos theta only goes between values of negative 1 and 1. That actually has no solution. But if you do shift cos, you might say, all right, negative is quadrants 2 and 3. Do shift cos of 2. Error. Shift cos of 2. You won't get an answer. Cos of whatever always lies between negative 1 and 1. So we know we draw the cos curve. There's no solution to cos theta is negative 2. It just never happens. So these are your answers. Only 2 answers. 70 degrees, 32 minutes, and 289 degrees, 28 minutes. X squared x. Look, when they saw sine squared x or cos squared x, you don't change it here because we got cos squared and cos. It's a quadratic in the same type of thing, like cos. Here, yeah, I got a quadratic, but I got a problem. I got sec squared and I got a tan. But It's 1 plus tan squared x equals sec squared x. Remember our trig identity? Now if I change this sec squared x into 1 plus tan squared x, I now have a quadratic in tan x. So this is where our trig identities come into play as well. So sec squared is 1 plus tan squared x. I've replaced that with that. Minus 2 tan x, then minus 4 equals 0. And let's just combine the like terms, which are the numbers. Tan squared x minus 2 tan x minus 3 equals 0. It's like you've got xx, 3 and 1. What's it going to be? It's quadratic. Negative 3 plus 1. So we've got, don't write it as x, but it's tan of x plus 1. Tan of x minus 3 equals 0. Double check. Tan squared x minus 3 tan x plus tan x minus 3. Great. Now, girls, tan does not just go between 1 and negative 1. Tan goes infinity. Positive and negative. So therefore, tan of x plus 1 equals 0, or tan of x minus 3 equals 0. That means that tan x is negative 1. That one's an exact value. And the other one, tan x is 3. You need your calculator for. 2 and 4. Quadrants 2 and 4. Tan of x is negative 1. Yeah. Quadrants 2 and 4, what's the acute angle x? Tan of what is 1? Tan of 45. So quadrants 2 and 4 for 45 degrees. So this is 135 and 315. Now, tan x is 3. There's no exact value for that. So x, so again, which quadrants? Quadrants 1 and 3. Acute angle x. 71 degrees, 33 minutes. Draw it in quadrants 1. 34 minutes? Because is it 33 minutes? How many seconds? 50 something? Yeah, so 71 degrees, 34 minutes. 71 degrees, 34 minutes. So x equals, quadrant 1 is 71 degrees, 34 minutes. And quadrant 3 is 180 plus 71 degrees, 34 minutes. So we've got 71 degrees, 34 minutes and 251 degrees, 34 minutes. Eight cos squared x equals 2 sin x plus 7. To make sure you don't get it wrong, you're going to write the rule out. Because if you get a minus 1 instead of a plus 1, or a 1 minus or a 1 plus instead of a 1 minus, you're going to get the whole thing wrong. It's not going to factorize. So cos squared x plus sin squared x equals 1. Therefore, cos squared x equals 1 minus sin squared x. So we are replacing cos squared x with 1 minus sin squared x. What do I have to include? Do I just write it next to it, or do I put something there? Brackets and 8. 8 times 1 minus sin squared x equals 2 sin x plus 7. Expanding, 8 minus 8 sin squared x equals 2 sin x plus 7. Does anyone want to work with a negative x squared? No. What side do you take it to? Good. All to the right, but you can really write it on the left. So over gives me 8 sin squared x. The plus 2 sin x stays the same, doesn't it? The plus 7 stays the same, and it's minus 8, which is minus 1. Just be careful I'm taking it all over, plus 8 sine squared x, plus 2 sine x, plus 7 minus 8. Please don't use the quadratic formula. I'm sure we can factorise it. I don't think it's going to be 8 and 1. No way. It's going to be, I don't even think it's going to be 4 and 2. I'm just going to go 4x, 2x. Oh, yes, it is. Plus, minus. Plus 4x minus 2x. Let's go. So we've got 4 sine x minus 1 and 2 sine x plus 1. Let's just check. 8 sine squared x plus 4 sine x minus 2 sine x minus 1. All good. So therefore, you can just write 4 sine x minus 1 equals 0, or sine x is a quarter. And we've got 2 sine x plus 1 is 0, or that's just sine x is negative a half. One of them is exact, the other one's not. Quadrants 1 and 2 for the first one. The other one is quadrants 3 and 4. And then the acute angle for the first one, I'm not sure what it is yet. And the acute angle for the second one is 30 degrees. So for the second one, we've got x is quadrants 3 and 4. What have you got? Quadrants 3 and 4. Yep, 2, 10 and 3, 30. And for the first one, what's the acute angle x? 14 degrees, 29 minutes. So it'll be in there and in here. So that was scribbled out. So we've got x is 14 degrees, 29 minutes and 180 minus 14 degrees, 29 minutes, which is 14 degrees, 29 minutes and 165 degrees, 31 minutes. So you've got 4 answers. 14 degrees, 29 minutes, 100, oh, they're all there. Just box them up. 165 degrees, 31 minutes, 210, and 330. 4 answers. How are we going, all right? So the first thing that you've said to do is to change cot to 1 on 10. Does the 2 stay on the top? Yes. So we've got 3 tan alpha minus 2 over 10 alpha equals 5. This is like having the equation 3x minus 2 over x equals 5. What do you do with something like that? It's like this. What do you do? What do we do? We want to get rid of this x. You multiply through by x in this one. Here we multiply through by tan alpha. So what we're going to do is multiply through each term by tan alpha. So we've got 3 what? Tan squared alpha minus, if you multiply this by tan alpha, what do you get? Minus 2 equals 5 what? Tan alpha. Good. See what we've got now? Take everything to the left, put it equal to 0, factorise and solve. So we've got 3 tan squared alpha minus 5 tan alpha minus 2 equals 0. And it's going to be, let's go, 3x and x. I'd say it's going to be 2 and 1. I think so. So it's going to be 3 tan x alpha plus 1. And tan alpha, no they're not, minus 2 equals 0. Let's check. 3 tan squared alpha minus 6 tan alpha plus tan alpha minus 2. And so therefore 3 tan alpha plus 1 is 0, or tan alpha minus 2 is 0. In other words, tan alpha is negative a third, or tan alpha is 2. And we keep going. In quadrants 2 and 4, the acute angle alpha is whatever. 10 is positive in quadrants 1 and 3, and acute angle alpha is, anyone? 2 and 4 here and there. So your 18 sitting there and there, the 18, whatever it is, I'll just put it roughly, you don't have to write it out completely. So therefore alpha is, isn't it 180 minus 18 degrees 26 minutes and 360 minus 18 degrees 26 minutes, which is 161 degrees 34 minutes and 341 degrees 34 minutes. And this one is quadrants 1 and 3, quadrant 1, quadrant 3. So alpha is 63 degrees 26 minutes and 180 plus 63, 243, 26 minutes. So there's your 4 solutions. 1, 2, 3, 4. Okay, that's it.